Hello, this is Dr. Renee Dyer, and in this video we're going to be using the Texas Instruments BA II Plus to solve for N, or a time period, but we're looking at annuities. And an annuity is a finite series of payments, so it's payments that have an ending. There are two different types of annuities. You have an ordinary annuity and an annuity due. An ordinary annuity pays interest at the end of the period, whether it's monthly, quarterly, semi-annually, or annually. An annuity due pays the interest at the beginning. So if you're solving for both, you will find that the annuity due is always a larger number because there is an extra period of interest because it's being paid at the beginning of the time periods. So let's look at a problem here. How long will it take a payment of $1,500 per quarter to amortize a loan of $16,000 at 19% compounded quarterly? So this doesn't tell us anything about it being an annuity due or at the beginning of the period or anything. So we assume this is an ordinary annuity. And by default, that is how the calculator is set up. It is set up to solve for interest to be accrued at the end of the periods. So at the bottom of the screen, you can see that I have the time value of money keys, and I have what we're going to plug into those. So we're computing for N. Our IY is 19% compounded quarterly, so we divide 19 by 4. We are borrowing $16,000 because it's a loan. That money is coming to us, so that's positive. And the principal of a loan goes under present value. And then we're making payments, quarterly payments, of $1,500. So that's coming out of our pocket, so that's going to be a negative. Now, with the calculator, since we adjust N and IY for compounding periods, the calculator understands that that payment is quarterly. So let's put in our numbers. Remember to always clear time value of money before you begin. So we have 19 divided by 4 equals, and that is IY, $16,000. That's what we're borrowing. That's our principal, so that's PV. And we're going to make a payment of $1,500. That's going to be negative because we're paying it back, and that goes under payment. So we're going to compute N. So it would take 15.23 quarters. So we want our answer to be in yearly or annual amounts. So we undo what we normally do for N, for compounding quarterly, where we would normally take a year and multiply it times 4. Now we're going to take the quarters and divide by 4 to get the annual answer. So the first answer for the ordinary annuity is 3.8 years. So now we're going to solve the same problem, but this time we're going to solve it for an annuity due. So we have to make an adjustment with our calculator. The first thing we're going to do is clear time value of money. Then if you will look above the payment key, you'll see BGN. This means beginning. So we have to change our calculations to calculate for the interest to be accrued at the beginning of the period. So second and payment, then we do second, enter, which changes it to BGN, and second, compute, which quits. So now you see you have the BGN at the top. Want to make sure you have that for an annuity due, but then we want to also make sure we take it off after we're finished. So we're going to plug the same numbers in. 19 divided by 4 equals IY, $16,000 PV, $1,500 negative payment, and we're going to compute for N. Notice this time it was 14.24. So we're going to divide by 4, and it's 3.6, 3.56. So it would take us 3.8 years to pay off that loan as an ordinary annuity or paying it at the end of the period. It would take us 3.6, 3.56 years to pay it off if we made the payment at the beginning. So we're saving a little bit of interest by making that payment at the beginning of the quarter. So now that we've solved our problems, we want to turn that BGN off. You go through the exact same steps as we used to turn it on. So we do second payment, second enter, second quit, and you're ready to solve your next problem.